Hello students, welcome you once again to GK's Applied Maths classes. Today we are going to do financial mathematics. Under that we are going to do nominal and effective rate of interest. I have already put a video on this where I have introduced the concept of nominal and effective rate of interest, and I also solved all the problems from Cbse handbook. I hope it was useful. Today we are not going to waste our time in introducing the concept. I will put the link of the previous video in this, so that if you have any doubt regarding the introduction of effective and nominal rate of interest, you can have a look at it. Today we will do only problems related to nominal and effective rate of interest from ML Aggarwal. Okay. Before I continue, as usual, I request you to subscribe to the channel and also press the bell icon to get notifications of video that I post. And thank you for all the support that you have been rendering till now. Now let us make a beginning. You all know what is a nominal and effective rate of interest. Actually, in a nominal rate of interest, and if you compare it with effective rate of interest, nominal rate of interest is for 1 year. Suppose you are paying 10% for 1 year. You pay only once a year. So that is nominal rate of interest. But if it is compounded semi-annually, the 10% will not be 10% if you are paying that interest for 2 times in a year. It will become little more than 10%. That is what you call effective rate of interest. So the more the compounding, suppose you make it quarterly, it will be even higher than what it was semi-annually. If you make it monthly, the effective rate of interest will be more. So always remember, the effective rate of interest will be more than the nominal rate of interest, and effective rate of interest will definitely be more if the compounding increases. Okay. Of course, when you do it continuously, I mean for infinite period of time, it will come to a stagnating value, that is e power r minus 1. Now you also know the formulas related to effective and nominal rate of interest. The formula, I just mention it here. R effective equal to 1 plus r by m, the whole power m minus 1. Of course, if you want to convert it to percentage, you finally multiply it by 100. So this is the formula that we have been doing. Now here find the effective rate of return, which is equivalent to a stated rate of 5% compounded quarterly. So here my rate of interest is 8%. Rate of interest is 8%. So now you have to make it what? You have to make it quarterly, right? So m is 4, right? So now your rate of interest, I should become r by m. Your I will be 8 by, it is 4 times into r. So that will be 0.02%. Since you are paying it 4 times, the interest has to be divided by 4. Why it is 4 times? Because it is compounded quarterly. Now, what is the formula? R effective equal to 1 plus r by m, that is 0.02 whole power m minus 1. And you know, this is nothing but 1.02 whole power 4 minus 1, and this value is very clearly mentioned here, which is 1.0824 minus 1, which is 0.0824. To convert it to percentage, you multiply it by 100, so it will be 8.24%. Now what's the meaning? The meaning is, if it is a nominal rate of interest, it is 8%. Since that 8% is divided for 4 years, you're paying it for 4 years, in a year 4 times, so it is quarterly. The effectiveness of 8% is no longer 8%, you are almost paying more, you are paying 8.24. So if you pay it once, you pay only 8%, but if you pay 4 times in a year, it becomes 8.24. Is that clear? So that is the special. That is why it's called effective rate. The 8% in effect is not 8%, it will be 8.24. Why it increases from 8 to 8.24? Because you are not paying it once, you are paying it 4 times a year, right? So it is compounded quarterly. I hope it's clear. Now find the declared rate of return compounded semi-annually, which is equivalent to 6% effective rate of return. So here the effective rate of interest is given to you. So what is R effective? R effective rate of interest is 6%. This is given to you. R effective is 6%. Now what is the formula? R effective equal to 1 plus R by M the whole power M minus M. Of course, since it is a percentage, I do into 100. Correct? But now it is actually semi-annually. So my M will be 2. So I want to find what my R is. So since if you divide it by 100, it will be 0.066% equal to 1 plus R by M the whole square minus 1. We'll substitute for M little later. Now from this you get 1.06 equal to 1 plus R by M the whole square. So what is 1 plus R by M? 1 plus R by M is 1.06 to the power of 1 by 2. But you know 1.06 power 1 by 2, it's given as 1.0296. Correct? So what is R by M? R by M equal to subtract, you get 0.0296. So R equal to 0.0296 into M is 2. If you multiply this, I think you get the answer as 5.92. Of course, you have to multiply it by 100, okay, because it is rate, it is percentage. So multiply by 2 and then with 100. So you'll get 5.92%. So this is your nominal rate of interest. See, your nominal rate of interest should, suppose if you get the answer as 6.92, you're wrong. Why? Because my effective rate of interest itself is 6%. So how can I get my nominal rate to be more than the effective rate? So that is one way of cross-checking. So definitely your nominal rate of interest will be less than the effective rate of interest, because nominal rate is paid once a year, whereas effective rate is, because you are not paying once a year, it is compounded many times in a year, or if you pay it once in quarterly or semi-annually or monthly. Suppose if you are paying only once, nominal rate of interest and effective rate of interest both will be no different, they will be one and the same. Okay. Now let's go back to the next question. Find this is a spelling mistake. Find the effective rate which is equivalent to a nominal rate of 10% compounded monthly. When it is compounded monthly, there's always going to be the effective rate will be more, okay, than compared to half yearly or quarterly. Okay. So what is my R? R is 10%, and number of times I'm going to pay is 12. Why it is 12? Because you're compounding it monthly. In a year there are 12 months, so you multiply. Therefore, R effective equal to 1 plus, what is R by M? Your interest will be 10 divided by 12 into 100. 10 divided by 12 into 100, I think it is 0.00833. You can always refer to this value, it will be the same. It's another way of avoiding your calculation, not wasting your time. R by M, the whole power M minus 1. So this is 1 plus, what is R by M? I already got it. 0.00833 whole power 12 minus 1. So 1.00833, the value is known to me. It is 1.1047 minus 1. So which is 0.1047. To convert it to percentage, you always multiply it by 100. So I get 10.47. So this is my R effective. Let us compare it with my actual. It is 10%. Here it is 10.47. It is almost 10.5%. You are paying more. 0.5%. If the amount is big, it's a huge difference. I hope you understand that. Okay. Now let's go to the fourth question. In the fourth question, find the effective rate of return equivalent to a declared rate of 12% compounded if it is semi-annually, quarterly, monthly and continuously. In fact, if you want to study this chapter, I prefer to do only this problem. If you do this problem, this will make you to understand what happens if it is semi-annually, what happens if it is quarterly, what happens if it's monthly, what happens if it is continuously. So you will be able to understand the difference. So that will make things very clear to you. If you don't have time to go through the entire chapter, just do one problem like this. It will cover everything. Now let us go one by one and do it. So first of all, let me do semi-annually. If it is semi-annually, my interest, that is R by M, will be 12 by 2 into 100, which is 0.06. So what is R effective for this? R effective will be 1 plus R by M is 0.06 whole power 2 minus 1. Why it is whole power 2? Because it is semi-annually, you're going to pay 2 times. So this is the first subdivision. Okay, so it's clear to you. So this is 1.06, value is given 1.1236 minus 1, which is 1.236 multiplied by 100 to convert it to percentage. That will be 12.36%. So I'm done with it. If it is semi-annually, my 12% effectively means 12.36%. Okay. Now let us see what happens if it is quarterly. Second subdivision. My I will be 12 by 4 into 100, which I think it becomes 0.03, and my M will be 4 times a year because it is semi-annually. Here M is 2. Okay. Now what is the formula? R effective equal to 1 plus 0.03 the whole power 4 minus 1. The value is very clearly given. It is 1.1255 minus 1, which is around 0.1255. Not clear. The percentage I'm talking, okay, into 100. So it will be 12.55%. One way of cross-checking is definitely when it is quarterly, your effective rate must definitely be more than half yearly, and the half yearly must be definitely greater than the nominal rate of interest, that is 12%. So we are in the right direction. At least conceptually it is clear. Now let's go to the last part of it. The third subdivision. In the third subdivision, we are having monthly, right? So your effective rate of R will be 12 by 12 into 100. So it is 0.01, correct? Now your M is 12 here. So what is R effective? R effective will be 1 plus 0.01 whole power 12 minus 1. Now from this, the values are given to you. 1.1268 minus 1. So it will be 0.1268. To convert it to percentage, multiplied by 100, it will be 12.68%. Again, you compare it. See, gradually the interest rate is increasing. As I told you, the more you compound the amount of the interest that you are paying, if the number of times the interest is paid in a year increases, your effective rate of interest will also increase. Your 12 will not be 12, it will reflect it as 12.36 if it is semi-annually, it will be 12.55 if it is quarterly, and 12.68 if it is yearly, if it is monthly. See, it's almost 13, it's coming closer to 13. Now the fourth subdivision. What if it's continuous? So M is infinity. M is infinity. You pay forever. Okay. In a year you pay infinite number of times, theoretically. Okay. So what is R effective? R effective, the formula is e power R minus 1. Correct. Now what is e power R? E power 0.12 minus 1. Correct. 12 divided by 100. I is 12 divided by 100, which is 0.12. Now the value is given. What is that? It is 1.1275 minus 1, which is 12.75 if you multiply it by 100. So what I want you to also understand is, when it is semi-annually, it is 12.36. When it is quarterly, it is 12.55. When it is monthly, it is 12.68. In a year, if I pay 12 times, it is 12.68. If I pay infinite times, it doesn't mean that the value is going to become very large. It's not that it's going to become 30% or 40%. It is still 12.75 only. Okay, so any number of times you pay, okay, after a certain period, the value will stop increasing. It will revolve around 12.75. And finally, if it is continuously, it will be 12.75 only. You will not, your effective rate of interest, you pay any number of times in a month, it will not cross 12.75 if it is continuously. Am I clear? So that is something to compare. You see, if you compare all these values and understand the concept, your concept will become clear and also the problem becomes clear to you. And once you do this type of a question, one problem, you don't have to study any other question. Everything is covered in this. Okay, let's go to the fifth question. Mrs. Renu has two investments. One is 8.4% per annum compounded monthly. Other one is 8.5% per annum compounded semi-annually. One, the interest is less, compounding is more. In the other one, the interest is more, but the compounding is less. Here you are compounding 12 times in a year. Here you are compounding only 2 times a year, and he wants me to compare. See, just don't do the problem with numbers. Also understand the question. What is the question? One is having lesser interest than the other. But the first option is having more compounding. Second is having less compounding. So let us see what exactly happens. Okay. Now for the first subdivision, for the first part of this question, my rate of interest will be 8.4 divided by compounded monthly. So 12 into 100. So this is 7 times it will go. So it will be 0.007. And your M is 12. So what is R effective? R effective will be 1 plus 0.007 whole power 12 minus 1. So you know the value. It is 1.0873 minus 1, which is 0.0873 into 100. So it is basically 8.73%. So your effective rate of interest of 8.4% compounded monthly is actually 8.73. Okay, that finishes this part. Now, what if my interest is 8.5% compounded semi-annually? So I have to divide by 2. So it will be 0.0425. Okay, you can divide it and see. I think it's not so difficult. And M is 2. So what is R effective? R effective will be 1 plus 0.0425 whole power 2 minus 1. The value is known to me, so it is 1.0868 minus 1, which is 0.0868 into 100. So it is 8.68%. You know, 8.73% is greater than 8.68%. So the first option is better. Okay. Now let's go to the second one. The last sum. So now you can also understand the problem. You know, one is less interest compounded more. That is why the interest is high. Okay. The last one is Dipanshu wants to make an investment of rupees 10,000 for 5 years. I like this problem. So I tell you why this is very special. Dipanshu wants to make an investment of rupees 10,000 for 5 years. He has two options. First option fetches him a return of 8% compounded semi-annually, and the second fetches him 7.5% compounded quarterly. Interest is high, compounding is less. Here, interest is less, compounding is more. So he wants to know which is a better investment. So in this problem, these the values I am not going to use. So it will confuse you. All that I need to do is I just have to calculate my effective rate of interest, which depends only on the nominal rate of interest. So what is that? My I is 8 by, since it is semi-annually, 8 by 2 into 100, which is nothing but 0.04, and M is 2. So what is R effective? R effective is 1.04 the whole square minus 1. The value is known to be 1.0816 minus 1, which is 0.816 into 100, which is effectively 8.16%. You see, my 8% gives me an effect of 8.16 if I pay 2 times a year. Okay, that's done. Now I equal to 7.5 divided by 4 into 100. Why do I divide by 4? Because it is quarterly. So it will be 0.01875. You can always copy from here and write. Okay, definitely they'll give you these values. Now what is R effective? R effective is 1.01875 whole power 4 minus 1. That value is also given to you. 1.0771 minus 1, which is 0.0771 into 100. So what is the rate? 7.71%. So this interest rate is more than this. So the first option yields you a better return. So the answer is the first option is better. Is it clear? So I think with that we covered all the problems in ML Aggarwal. And there are other problems in that exercise which comes under CAGR, otherwise called compounded annual growth rate, which we will do in the next video. And kindly subscribe to my channel and also click the bell icon to get notifications of the videos that I post. Thank you for all the support. I hope these videos are very useful. We are going to continue doing problems from all chapters, both from ML Aggarwal as well as from Cbse handbook. Have a great day. See you then in the next video. Bye bye until then.